You know what I really like to do? Come up with chemistry slams for people who really piss me off. One of my favorites. Yeah? Well, your Ka is less than 1, because you're weak. Gets him every time. Find the hydroxide ion concentration and pH of a 0.100 molar ammonia solution. The Kb of ammonia is 1.76 times 10 to the minus 5. Ooh. First thing I'm going to do, I'm going to write out my equation for ammonia in water. Boom. Recognize here that ammonia is acting as a weak base. One, we're told that the Kb of ammonia is 1.76 times 10 to the minus 5. And two, ammonia is just one of those things that you should know at this point is a weak base. All right, first let's find the hydroxide ion concentration. We're going to treat it just like we would our weak acids. We're going to set up an ice table, boom, because weak bases, just like weak acids, don't completely ionize in solution. So we can't just use the stoichiometry. We're going to drop our pure liquid. Initial concentration, 0.100 molar. Initial concentrations of hydroxide and ammonium ion, 0.00 molar. Think about stoichiometrically how these things are going to change. And then at equilibrium, our concentrations, boom. Our Kb expression, always write it in terms of the species in your equation first. Boom. And then plug in the equilibrium concentrations that you came up with in your ice table. We know the value of Kb is 1.76 times 10 to the minus 5. Boom. Now, importantly, I'm going to do X is small approximation can be made because initial concentration of NH3 and Kb differ by a factor greater than 1,000. Always be explicit. Don't just drop your X and move on. But that works out nicely to simplify our expression to 1.76 times 10 to the minus 5 is equal to x squared over 0.100. All right, let's solve for x. Parentheses 1.76 second e negative 5 close parentheses times 0.1 enter. Second square root second answer. X equals 1.33 times 10 to the minus 3 molar. That is our hydroxide ion concentration. Boom. First part of this question done. Finito. But we also want the pH. Couple different ways that you can do this. Because I have a hydroxide ion concentration, I'm going to do pOH is equal to the negative log of hydroxide ion concentration. So I'm simply going to plug in my concentration that I solved for earlier, and then jump to my calculator. Negative log second answer. So my pOH, I have 3 sig figs, so I'm going to do 3 after the decimal, 2.877. But be careful, it wants pH. So recognize that pOH plus pH equals 14. We just determined the pH to be 2.877. So a quick jump to our calculator. 14 minus 2.877. Our pH is equal to 11.123. Boom. Again, always stop and ask yourself at the end, is the pH that you calculated for even make sense for the solution that you're working with? If I'm working with a basic solution, should I have a pH greater than 7? Answer, yes, it makes sense. Done.